Okay, so in exercise 141, number 5, we have a situation here where we need to find angle y and angle x. Angle y and angle x. So we could first find angle y very easily, which is this angle here, by saying that the three angles in that triangle there must add up to 180. Okay, so that's the easy part. So we'd say 50 degrees plus 70 degrees plus angle y is equal to 180 degrees. And that's because the angles in a triangle are supplementary. Alright, so therefore, angle y will be equal to 180 minus 70 degrees minus 50 degrees. So this will work out to be 60 degrees. So angle y is equal to 60 degrees. So that's one answer because they wanted us to solve for angle y. The next one is to find angle x. So there are different ways to do it. Let's just do some extension here to see if this will help us in any way. All right. But one sure thing that we could find is that if this is angle y, we know that this angle in here would also be angle y. And that's because those are vertically opposite angles. Okay? So that's definitely one easy thing we could do once we get that. The next thing that is easy to see is that if this is angle y, which we know, this is the next angle in that triangle is 80, we could find the other angle in the triangle, which is this one here. And if we know that angle, we could then find x by subtracting it from 180 degrees. Okay? That's one method. So we could go through that very quickly. And we could say, if we call this A, B, C, we could say, we could put it in this way. We could say that angle C, AB must be equal to angle y. So what is CAB? Going from C to A and back to B. That is angle y. That angle must be equal to angle y. And the reason is that they are vertically opposite angles. Okay, they are vertically opposite angles. And in that case, if CAB is equal to angle y, it means that CAB would be equal to 60 degrees. Okay? And then, if we look at the triangle ABC, then we say that the angles in there must add up to 180. So we could say that 60 degrees, which is angle y or angle CAB, plus 80 degrees plus the unknown angle, right? That unknown angle, we could call it theta. So we could say plus theta must be equal to 180 degrees. And you could write that angles in a triangle are supplementary. So it means therefore that 60 plus 80, which is 140, plus theta is equal to 180 degrees. And therefore we could find that theta will be 180 minus 140, which is equal to 40 degrees. So if we know that this is 140 degrees, sorry, we know that theta is now, we know that that is 40 degrees, then we could easily find what x is by saying 40 plus x must be equal to 180. And the reason is that those two lie on a straight line. Okay? And if those angles are on a straight line, it means then that we could solve for angle x, which is 180 minus 40, which is equal to 140 degrees. So angle x is equal to 140 degrees. And we would have therefore solved what they asked us to solve. So that also is an answer. This is one of the answers they're looking for. Angle x is equal to 140 degrees. Okay, so we're looking at exercise 147, number 8. Right, exercise 147, number 8, certificate maths. And here we have a quadrilateral that has a subdivision. Okay, so if we call the vertices A, B, C, D, and we label the intermediate point E, right, then we could talk more effectively about what we have on the board. So if we consider A, B, C, D, right, that's a quadrilateral. A, B, C, D is a quadrilateral. And we know the sum of the internal angles of any quadrilateral is 360 degrees. If by any chance you forgot, you could use the equation, sum of the internal angles is 2n minus 4 by 90 degrees, where n represents the number of sides. So you would have been able to calculate it. Now, so therefore, if we consider A, B, C, D, right, then we could say that 100 degrees plus 110 degrees, right, so we're adding the interior angles, plus this whole angle here, which would be A plus A, or 2A degrees. So we're adding that as well, plus 2A plus 80 degrees. Those will be the sum of the internal angles of A, B, C, D. So we could say that those angles, when added together, will give us 360 degrees. And of course, the reason for that is that these are angles in a quadrilateral. And angles in a quadrilateral sum up to 360 degrees. So then we can work out that by saying 2A will be equal to 360 degrees minus 100 minus 110 minus 80. So therefore 2A will be equal to, and we have to work out that. Okay, so 2A therefore is equal to 70 degrees when you work the right hand side out. And that therefore tells us that angle A will be equal to 70 degrees over 2, which really is equal to 35 degrees. So if we know A is 35 degrees, it means that here is 35 and here is 35. Okay, so we know each one of those are 35. So if we now consider the triangle ECD, if we consider the triangle ECD, then what we could say is that angle P plus 80 degrees plus 35 degrees must be equal to 180 degrees. Okay, so angle P therefore must be equal to 180 degrees minus 80 degrees minus 35 degrees. Okay. So P plus 80 plus 35 equal to 180 degrees because we are looking at the triangle ECD and we're adding up the internal angles. And that, of course, is because the angles in a triangle are supplementary. So therefore, angle P will be equal to, and we have to calculate that. So angle P therefore works out to be 65 degrees, and this is what they asked us to find. So that's your answer, and you underline it. Okay, so we on to a topic called bearings. And what you'll do is write this as a note. One way of describing the position of one object, relative to another. One way of describing the position of one object relative to another is called its bearing. It's called its bearing. It's called its bearing. Full stop. This is the angle. This is the angle measured in a clockwise direction this is the bearing. This is the angle measured in a clockwise direction from north to the object. From north to the object. Full stop. This is the angle measured in a clockwise direction from north to the object. From north to the object. Full stop. Bearings are always written using 3 digits. Thus north is 0, 0, 0 degrees. East would be 0, 9, 0 degrees. South would be 180 degrees. And west west would be 270 degrees. Right, if you had to write the bearing. Because if we look at our cardinal points, we know that north starts here, so that would be 0, 0, 0 degrees. Then east will be on the right-hand side, west will be on the left-hand side. A way to remember it easily is to remember the word we. So west will be left and east will be right. And right below north is south. So east will be 90 degrees, which is represented as 090 degrees. South will be represented as 180 degrees. And west, as we said, will be 270 degrees. So this is how we get it from the cardinal directions. So if we had an example to look at, our first example, where we said the bearing of B from A is 065 degrees. The bearing of B from A is 065 degrees, and we wanted to represent that. The first step is that we must first draw a north arrow from A. So the first step, or step 1, will be to draw a north arrow from A. And it is critical that we know where to start from and where to draw a north arrow from. And that is told to us all the time in the question, because they always say the bearing of somewhere from somewhere else. And it is this word from that tells us where we have to start our drawing from. We always start from wherever they tell us. In this case, they tell us from A. So we are going to start from A, put a point down on the paper, and draw a north arrow. The next step, which is step 2, will be to measure an angle of 65 degrees from that north arrow in a clockwise direction until we are pointing to the direction of B. So we will measure the required angle, which in this case is 65 degrees, from the arrow, the north arrow that is, measure 65 degrees from the north arrow in a particular sense or direction, and that will be in a clockwise direction. Clockwise direction. Until we are pointing in the direction of B. Okay, so this is the procedure, how you would go about doing that. And we said that the first step is to draw a north arrow from where? And the answer is from A. So this is what is critical in determining how to do these things. So we say from A, we will draw we'd start at A and we would draw a north arrow. So we'd come A and draw a north arrow. That would be your north arrow there. And then you measure 65 degrees from the north arrow in a clockwise direction, which means we put our compass, our protractor center at A, let the zero line on the protractor lie in the direction from A to N, and measure 65 degrees in a clockwise sense. So that would take us, if we measure our 65 degrees, let's say it took us to this point, and then we would measure or draw our arrow pointing towards B. Okay, because we have to measure that 65 degrees from the north arrow in a clockwise direction until we point in the direction of B. So B would lie along that line, and this here will be a 65 degrees. But for bearings, remember to put in our 0. So it will be 0, 65 degrees. If you, in bearings, you do not put in your 0, in the case of a 2-digit bearing, a 2-digit angle, sorry, then you would lose mark. So you need to always remember in bearings, you place your zeros in. So 065 degrees would be the appropriate bearing. Okay, so in our second example, the first part, A, it said to us that the bearing of a point A from a point B is 075 degrees. State the bearing of B from A. State the bearing of B from A. Now, the critical point here is, where do we start to draw from? Do we put down A and draw north and then measure the angle, or do we put down B? And it's right here in the statement of the question, because they said the bearing of a point A from a point B. So this is what tells us where we will start our drawing from. The word from a point B. So we're going to start from B. Okay, so we start from B. That represents point B. And they said the bearing of a point A from a point B. So it means from B now, our first step is to draw our north line. Draw our north line. And then we measure, or we place 75 degrees. Now, in some of these questions, like this one, for example, we could actually use the properties that we learned, that is corresponding angles, vertically opposite, alternate, and so on, to calculate the angle. So we don't have to actually measure it out. That's important. You don't have to actually measure it out. You could calculate it, and that's what we will be using in these questions here. So the bearing of a point A from a point B, our first step tells us start from wherever they said, which was point B, draw your north line, and then state or place your 75 degrees, which in this case is the bearing that we're looking at, moving clockwise from north, and along that line we will find the point A somewhere. So if we think back and read it, the bearing of a point A from a point B, which means starting at B, if we measure 75 degrees, we'll measure and we'll point in the direction towards A. So the bearing of a point A from a point B is 075 degrees. State the bearing of B from A. So if we have to do this part of the question, it means now we have to position ourselves at A and start from that point. So start from A, draw a north line, as we would have done before. Start from A now, draw a north line, and see what angle we have to go through to point back to B. It means we'd have to go through this angle now to point back towards B, if we are starting from A, which is the question they're asking us to solve. So how do we go about getting that particular angle? That angle that they are asking about. If we were to call that particular angle theta, then this is what we are interested in. How are we going to go about finding theta? Because that is the angle that would give us the bearing of B from A, starting from A. So what we do, if we extend this line here upwards, like this, and we take note of this angle here, and let us say we call that angle alpha. Let's say we call that angle alpha. Then we could say that angle alpha would be a corresponding angle to 75 degrees, because there are two north lines which are parallel lines, and there's an inclined line that runs from B to A and extends further out. Let's say it extended to point C. So BAC is an extended inclined line to the two parallel lines which are the north lines. So therefore, angle alpha is corresponding to the angle 75 degrees located in the first position, right? Or in the position from the north to B to C, that angle. So we could write that angle alpha is equal to 75 degrees because those are corresponding angles. Right? So if we know angle alpha is equal to 75 degrees, and we are interested in angle theta, well then if we look at angle theta, we could say that angle theta is equal to alpha, which is 75 degrees, plus 180 degrees. Because if I come from here now, you could clearly see that that is 180 degrees right there. So if I add alpha and 180, I'll get the required bearing theta. Yes? Theta starts from the north position and goes all the way around. That's the bearing you're looking for. So we write, therefore, angle theta, which is the bearing we're interested in, will be equal to alpha plus 180, which is the same thing as saying 75 plus 180. So our required bearing will be equal to 255 degrees when you add them up. And therefore, this would be our answer that they were looking for. That's the answer they're looking for. Okay, so theta, the angle theta, was the required bearing of B from A. Right? The required bearing of B from A was the angle theta. In example 2b, we are told that the bearing of a point Q from a point P is 325 degrees. What is the bearing of P from Q? What is the bearing of P from Q? What I'd like you to do is to try on your own to come up with the diagram. See what the diagram would look like. Don't try to figure it out, but try to put on a diagram that would represent the information stated here. And then we'll continue from that point. Okay, try it and see. Okay, so we're looking at the bearing of a point Q from a point P is 325. So because I said from a point P in the first part, that is where I will start from. I will start from P. So I come here and I say, well, listen, this will be point P. And I draw my north position, as always with bearings. I draw my north position. And then I start to go through the angle. Now, if this had started here and gone clockwise, and it reached this point here would have been 90 degrees. But it didn't say 90. Let's continue. If I had gone down to this point here, that would have been 180 degrees. But it didn't say 180. If I had continued going even further now, to this point here, that would have been 270 degrees because I'll have gone all this distance here. If I continued going until I line back up with the north position, that would have been 360 degree movement. 360 degree all the way across. So it means that if I'm to go 325 degrees, I'd have to be somewhere between 270 and 360. So we could say that 325 will be somewhere between these two positions. Okay, so the 325 degrees that they spoke about would be the movement that goes from all the way back to here. Okay, and that would be a 325 degrees, starting from P and moving towards Q. The arrow will point towards Q eventually. So let's say that is where Q ended up being. Their question to us is, what is the bearing of P from Q? Their question is, what is the bearing of point P from Q? So now we have to start off at Q. Draw our north line. That'll be our north line there. And we have to find what angle we must go through from starting with this north and ticking like the hand of a clock until we point back towards P. What is the bearing of P from Q? So start from Q now, draw north, and see how that north must move until it points back in the direction of P, which means we must move through this angle here. And that, therefore, is the angle we're interested in. If we call this angle alpha, then alpha would be equal to what we are looking for, the bearing of P from Q. That will be exactly what we are looking for. This angle alpha here will be the bearing of P from Q. Okay? And therefore, we could start to work on that. If we extend here, let's call this angle here beta, just to speak about it so we could talk about it easily. And we would recognize that there's an angle that we could get a value for, which is this angle here. Let's call that angle theta. And how could we get the value of theta? We could get the value of theta by recognizing that 325 plus theta will be 360 degrees. Right? Because if we started from here and we went all the way around until we end up at this point here, and that was 325, if we went theta degrees more, we would have gotten 360 degrees. So we could say that 325 degrees plus angle theta would give us 360 degrees, because those angles are in a circle. So therefore, we could say that angle theta is equal to 360 minus 325. And therefore, angle theta will be equal to, and we can calculate that, 35 degrees. Now, if we know angle theta, we also know angle beta, because beta and theta are inside of a special z. And those angles are said to be alternate angles, and alternate angles are equal. So we could say that theta is equal to beta, and that therefore means that beta is equal to 35 degrees. And the reason is that those angles are alternate angles. Right? Those are alternate angles. So if we know beta is equal to 35 degrees, and of course we calculated that theta was also equal to 35 degrees, then we could easily find angle alpha, which is the bearing of P from Q, by noting the fact that angle beta plus angle alpha must be equal to 180 degrees. And the reason is that those angles are in a straight line. Those angles are on a straight line. So if we know beta is 35 degrees, we could write 35 degrees therefore plus alpha is 180. And therefore, alpha is equal to 180 degrees minus 35 degrees. And 180 degrees minus 35 degrees is 145 degrees. And that is our required bearing of P from Q. So this would be our answer right here. Okay, so under basic trigonometry, there are three basic ratios: sine theta, cosine theta, and tangent theta, shortened to sine theta, cosine theta, and tan theta. You write in the following acronym, ACRONYM, the following acronym helps us to remember the construction of these ratios. Helps us to remember the construction of these ratios. Full stop. These ratios apply for all right angle triangles. These ratios apply for all right angle triangles. And only right angle triangles. These ratios apply for all right angle triangles and only right angle triangles. Full stop. The acronym that we will use to help us remember them right? The acronym we shall use is SOHCAHTOA. 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 And what does SOHCAHTOA mean? SOHCAHTOA means that sine is opposite over hypotenuse. So the O will stand for opposite. And the H will stand for hypotenuse. So we say that sine is opposite over hypotenuse. The CAH says that cosine, C for cosine, the cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And the TOA means that T for tangent or tan is equal to opposite over adjacent. The tangent is opposite over adjacent. So if we were to summarize, we could summarize by saying sine theta is equal to opposite over hypotenuse. And we could summarize what cosine is as well. We could summarize by saying cosine theta would be equal to, in this case, adjacent over hypotenuse right? That's what cosine theta is. And then we could summarize tan theta after that by saying tan theta is opposite over adjacent. And we'll shorten opposite to OPP and adjacent to ADJ, right? Because of the space. Okay, so these are what you are required to know. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. So let us consider the following right angle triangles. In the first case, we revise what the general triangle is made up of. Now in the general triangle, if we label the vertices A, B, and C, then we use capital letters to represent those vertices. Now those letters could be any letters, P, Q, R, L, M, N. It doesn't matter. They go in one sense or the other. In this case, it goes in a clockwise sense, A, B, C. And the angles at each vertex carries the same capital letter, but with a little hat on top. So that'll be angle A at the top. To the right will be angle B, and to the left will be angle C. In this case, angle C is the right angle. In this case, angle C is the right angle, or 90 degrees. This here really means 90 degrees. And also, opposite to angle C or vertex C will be the side AB, whose length will be common C in length. Opposite the angle B will be the side AC, whose length will be denoted by common B. And opposite the vertex A will be the side CB, whose length will be denoted by common A. This is the way that triangles are spoken about in general. Now, there's something else you are supposed to know. We learned from SOHCAHTOA that there's opposite, adjacent, and hypotenuse. But how do you identify opposite? How do you identify adjacent? How do you identify hypotenuse? Hypotenuse is always opposite the right angle. So in this case, opposite right angle at C will be the length AB. So the hypotenuse in this case will be AB. So AB is the hypotenuse. And the hypotenuse is always the longest side. And it's always opposite the right angle. That's how we identify the hypotenuse. The next thing we need to identify is the opposite side. Okay, and in this case, the opposite side will be the side opposite the angle theta, which will be CB. So CB will be the opposite side. CB will be the opposite side, and it is the side furthest away from the angle being considered. It is the side furthest away from the angle being considered, and that is the opposite side in this case. And the only remaining side is the side AC, which will be the adjacent side. Right? So we say AC is the adjacent side. And AC will be the side that is the nearest to the angle being considered. That is the adjacent side. So the adjacent side is always the side nearest to the angle being considered. In this case, the angle being considered is labeled theta. So that will be the angle theta in both cases. So if we look at these two examples, in the first example, if we were asked to find cosine theta, we'd say that cosine theta we learned in SOHCAHTOA, the cosine was the adjacent over the hypotenuse in SOHCAHTOA. So we could write adjacent ADJ over hypotenuse HYP to shorten it, and that would work out to be, in this case, we would have to identify the angle being considered, which is, in this case, is theta at the bottom, and cosine theta would be adjacent over hypotenuse. Adjacent in this case would be the side nearest to that angle theta, which would be the side CB, and the hypotenuse will be the side that is opposite to the right angle, which in this case will be the side AB. So here will be opposite. Sorry, here will be hypotenuse. Here will be adjacent. And here will be opposite, because this will be the side furthest away from theta, which is the angle being considered. So we could say that cosine is adjacent over hypotenuse, which will be CB over AB, because AB is the hypotenuse. Then we could say that sine theta is, from SOHCAHTOA, sine is opposite over hypotenuse. And we could say that sine theta would be AC over AB, because AC was opposite and AB was hypotenuse. And then tan theta, from SOHCAHTOA, tan theta is opposite over adjacent. And in this case, opposite will be AC and adjacent will be CB. Okay, so look at number 2 and see if you could come up with what this cosine, sine, and tan should be in number 2 based on what we just did. So if we were looking at this one, number 2, where we had to find cosine, what we would do first is identify which side is opposite, which side is adjacent, which side is hypotenuse. So opposite hypotenuse would be the side that is opposite the right angle, which means that XZ will be the hypotenuse in this triangle. The opposite side will be the side furthest away from the angle being considered, which is theta, and therefore XY would be the opposite side. And the adjacent side will be the side closest to the angle being considered, that is closest to theta, and that will be the side YZ, so that will be adjacent. So based on that, we could find what cosine theta would be. Cosine theta in this case we know is adjacent over hypotenuse. And adjacent over hypotenuse for this one will be YZ over XZ. Right, so that's what you should have gotten. Adjacent over hypotenuse should be YZ over XZ. Sine theta is opposite over hypotenuse from SOHCAHTOA. And opposite in this case is XY, hypotenuse is XZ. So it will be XY over XZ. And then tan theta from SOHCAHTOA we learned was opposite over adjacent. And in this case, opposite is XY and adjacent is YZ. So it will be XY over YZ. Okay, so that's what you should have gotten when you did it. Make sure you understand that, because this is how we would work out everything. We must know how to identify opposite, adjacent, and hypotenuse, and then remember the ratios, sine, cosine, and tan, and just substitute what we need to substitute. Okay, so in our part 3, we had to find certain things. In our part 3, we had to find certain things. In number 3, they asked us to find what sine theta was. In number 3, they asked us to find what sine theta was. Okay, so we have to find sine theta in number 3. And we know that sine theta from SOHCAHTOA, sine theta is opposite over hypotenuse. In this case, opposite would have to be identified relative to the angle. The angle is not stated there. So we'd have to locate the angle first, and then we could find the opposite. In this case, opposite was here. Sorry, the angle theta was down at the corner of vertex B. So opposite would be the side furthest away from that, which will be AC. And hypotenuse would be the longest side, or the side opposite to the right angle, which would be AB. So AC would be 3, and AB would be 5. So our answer is sine theta is equal to 3 over 5, or if you want, you could write it as a decimal and you could write 0.6. Sine theta is 0.6 or 3/5. And that would be the answer right there. You stop right there because it just asks you for sine theta. That's it. So we're looking at the next example, which is number 4. And they're asking us in this one to find XZ, to find the side XZ. Now this is different, and you need to pay attention here, because here is how do you know whether to use sine, cosine, theta, cosine theta, or tan theta. How do I decide which one I'm going to use? Right? That's a big decision that we have to come up with. So let us see what we do. We observe that xz relative to 30 degrees is opposite. And we have to be given something else in order to solve this. The other thing they gave us was the length from y to z, which was 5 centimeters. Now that length yz is opposite the right angle. So it means that that length yz is really the hypotenuse. The question we ask ourselves is this: which ratio out of sine, cosine, and tan, which one of them connects what we want to find, which is opposite, to what we know already, which is hypotenuse? Out of the three ratios, sine, cosine, and tan, which one has opposite and hypotenuse in it? Sine. Is there any other one that has opposite and hypotenuse in it? No. So the only one that we could use is sine, because it connects what we want to find, which is opposite, to what we already know, which is hypotenuse. And that's why we have to use sine. There's no other one that connects those two. So we write sine theta is equal to opposite over hypotenuse. Opposite over hypotenuse. In this case, it will be xz. Sine theta will be equal to xz over 5. So if we cross multiply by, first of all, putting sine theta over 1, we could say if we cross multiply, xz multiplied by 1 must be equal to sine theta multiplied by 5. So we could write that here. We could say xz by 1, which is xz, is equal to sine theta by 5, or 5 sine theta. But in this case, theta is 30 degrees, so we'll put that in there now, sine 30 degrees. So xz is 5 multiplied by sine 30. And if you put that into your calculator and do your checks there, you should get an answer of 2.5 centimeters when you multiply. Always remember, of course, to ensure that your calculator is in the degree mode. Right? It's not in radian or gradient. Make sure it's in degree mode by pressing the DRG button. Or if you cannot find that button for any reason, you could reset it by pressing the reset button at the back of the calculator. So when you do that multiplication, you should get a value of 2.5, and the unit in this case for length is centimeter. So you should get an answer of 2.5 centimeters for number 4. In number 5, we are asked to find AC, the length AC. In this case, AC is the side opposite to the right angle, and that will be the hypotenuse. So AC is the hypotenuse in this case. So we are being asked to find the hypotenuse. Again, we have to make a decision whether we are going to use sine, cosine, or tan. So we ask ourselves, what is it that we have? And what is it that we want to find? We have 60 degrees, which is an angle. So we have theta. We have a side that is opposite theta. We have that length, 4 centimeter. So we have opposite, right? That's what we have. And we want to find hypotenuse, which is AC. So we ask ourselves, what connects what we have to what we want to find? And the only ratio that connects what we have, which is opposite, to what we want to find, which is hypotenuse, is sine. Sine is the only ratio that does that. So we again will be using the fact that sine theta is opposite over hypotenuse, which is what we have is opposite what we want to find as hypotenuse. So that's why we will be using sine, because it's the only ratio that connects those two. We could write that sine 60 degrees will be equal to opposite, which is BC, 4 centimeters, over hypotenuse, which is AC. That is what we want to find. So if we put sine 60 over 1 and cross multiply now, we'll get 4 multiplied by 1 is sine 60 multiplied by AC. So we could write that as AC, when you multiply AC by sine 60 or sine 60 by AC, we could write that AC sine 60 degrees is equal to 4 multiplied by 1, or 4. And therefore we could get what AC is by saying AC will be equal to 4 over sine 60 degrees. In other words, we're dividing both sides by sine 60. And therefore, from here, we could find what the length AC would be equal to by taking 4 and dividing it by sine 60, making sure that you have your calculator in the degree mode. And you will get an answer of 4.62 centimeters if you round it off to 2 decimal places. To 2 decimal places. So we're looking at number 6, which was find theta, which is find theta. We want to find theta. Now this one is one that you have to pay particular attention to because it's a little bit different from the others that we did before. We'll be using something known as the inverse function, right? Or the inverse trigonometric function in this case. Anytime you have to find an angle, you have to use something called the inverse function. So let's see what happens. In this case, you want to find theta, and you are given the side that is opposite to theta, and you are given the side that is opposite to the right angle, which is the hypotenuse. So you ask yourself, which ratio out of sine, cosine, and tan connects opposite and hypotenuse? Again, the answer is sine. So we write sine theta is equal to opposite over hypotenuse, which means that sine theta will be equal to, in this case, opposite is CB, and that is 4 centimeters, over the hypotenuse, which in this case is AB, and that's 5 centimeters. So 4 centimeters over 5 centimeters, or 4/5, is theta. And this is where it's different from the others, something new that you learned today if you didn't know it before. And we say that anytime we need to find an angle, and we have sine of that angle is a number, or cosine of that angle is a number, or tan of that unknown angle is a number, you have to use the inverse function. So in this case, we'll have to say theta is equal to the inverse sine, or sine to the minus 1 of whatever the number is. In this case, it's 4 over 5, or 4/5. If it was cosine theta, you'd have to use the inverse cosine. And if it's tan theta, you'd have to use the inverse tan. Good? So in this case, it was sine. So we use inverse sine. And therefore, if you go to your calculator and you press second function sine, right? Second function sine, and put in brackets 4 over 5, close brackets. Making sure your calculator is in the degree mode, you should get this answer, 53.13 degrees. So you should get your answer as theta is equal to 53.13 degrees. Right? So this 53.13 degrees was to 2 decimal places. To 2 decimal places. And be careful when you're doing it. In some calculators, you may need to put brackets around the numbers. If you don't put brackets, sometimes you mightn't get it correct. So the safest thing to do is to press second function, press the sign button, press open brackets, and then put in the numbers 4 use the button A and B over C, and then press 5, close your brackets, and press equal. You'll get 53.13 degrees to 2 decimal places. Okay, so a closing note, because if you notice, everything we did here was for sine, right? So the closing note will cover the other ratios. So just quickly write it. This closing note will summarize, because in all of these cases, we did examples with sine, but what happened with cosine and tan? This note will summarize it for you. And it goes, cosine theta and tan theta, cosine theta and tan theta follow the same principles. Cosine theta and tan theta follow the same principles. Full stop. Simplifying the ratio that connects what you want to find, simplifying the ratio that connects what you want to find, open brackets, the unknown, close brackets, open brackets, the unknown, close brackets, with what you know, with what you know, such that an equation with only one unknown, is created. Full stop. If theta is to be found, after created, full stop, then write, if theta is to be found, we always use the inverse function. If theta is to be found, we always use the inverse function, i.e., that is, sine to the minus 1 theta cosine to the minus 1 theta, or tan to the minus 1 theta. To find it. Okay, so that closes it off. The homework is as shown on the board there. Right? Exercise 161 would cover bearings. Exercise 155, 5 to 11. Exercise 156, 3 to 9. Exercise 157, 3 to 9. Yes, so the homework for this session will be exercise 161 in certificate maths, exercise 155, 5 to 11, exercise 156, 3 to 9, and exercise 157, 3 to 9. Okay? Good. That was exercise 161. Okay? And this was 156. Okay, and 155. Okay. Okay, so we are looking at exercise 147, number 6 in certificate maths, and we are asked to find out what x is, or to put x in terms of a, b, and c, or what is the relationship, right? What relationship can we find between x and the other letters or angles in the diagram? So what we could say is that this angle here plus x must be equal to 360 degrees. So we could write that whatever this is here, let's call this angle here theta. We could say that theta plus x must be equal to 360 degrees. And the reason is that these angles are in a circle. So if these angles are in a circle, then the relationship x plus theta, or theta plus x, is equal to 360. So theta will be equal to 360 minus x. So if we put that in here, theta is equal to 360 minus x, then we could use the fact that inside of that shape, whatever it may be, the sum of the internal angles must be equal to something, right? And whatever it is, we could work it out, because we have the formula for working out the sum of the internal angles of an n-sided polygon. Okay? Now, if I label this shape A, B, C, and I call this point here D, then how many sides does it have? A to B is 1, B to C is 2, C to D is 3, and D to A is 4. So therefore, that is a quadrilateral because it has 4 sides. And we know that the sum of the internal angles in a quadrilateral is 360 degrees. So therefore, we could say that angle A plus angle B plus angle C plus angle theta must be equal to 360 degrees. Okay, because the sum of the internal angles of a quadrilateral must be equal to 360 degrees. So what we could say now is that A plus B plus C plus 360 minus x, because remember we worked out that theta is 360 minus x. So we make that substitution, and that will be equal to 360 degrees. So therefore, if we open up the brackets, because it's a plus sign, it has no effect, so it'll just be plus 360 degrees minus x equal to 360 degrees. Now if we minus 360 on both sides, right? If we minus 360 on both sides, what happens? You get A plus B plus C minus x is equal to 0. In other words, minus 360 here, this will come out. Minus 360 on the right hand side, you get 0. We minus 360 on both sides. And therefore, A plus B plus C will be equal to x. How come? Well, we add x on the left hand side, cancels. We add x on the right hand side, so you have x. So A plus B plus C is equal to x, or x is equal to A plus B plus C. And in this question, that will be equal to our answer A. Answer A plus B plus C. That is option A. Okay, in exercise 147, number 7, we are asked to find what is angle y. We are asked to find the value of angle y. Okay, so let's see what we observe. This line here is parallel to this line here. Okay? So it means that there are certain similarities that we could look at. And if we identify this here as a special z, that I have shown you there, because these two lines are parallel, it's a special z, then angle y and this angle here will be alternate angles because they are included in that special z. One on this side, one on that side. So this angle will be angle y. This is important. So let's call that angle there alpha. Now, let's go back a little bit. We have certain angles, and if we label, it'll be easier to speak about it. So let's call that corner A, this here B, C, D. Okay? So if we look at the triangle ABD, that triangle, we could find this angle here, which I'll call theta. Okay? And if we find that angle theta, and we know that the angle ADC is 80 degrees, then we could find the other angle at the bottom here very easily. Let's call that angle beta. If we find beta, then using the triangle DBC, we could find what alpha is by saying when you add those three, you get 180, and we could solve it. You could find what this one is. And seeing that these two are alternate angles, then you would know what angle y is. So I'll do it step by step now so you'll see what I'm talking about. So let us consider the triangle ABD. So you're looking at that triangle, ABD. Look at that triangle. If we add the three angles inside of there, which is the 100 degrees, the 40 degrees, and what we have labeled as theta, then we know that those three must sum up to 180 degrees, because the angles in a triangle are supplementary. That means they add up to 180 degrees. Right? They add up to 180 degrees. So we could say that angle theta plus 100 plus 40, which is 140 degrees, will be equal to 180 degrees. And therefore, angle theta must be equal to 180 degrees minus 140 degrees. So it means then that angle theta is equal to 40 degrees. Now we know if angle theta is equal to 40 degrees now, we know that, we just worked it out. We could easily find what angle beta is by the relationship theta plus beta is equal to 80 degrees. Right? You see it there? Theta plus beta is equal to 80 degrees. Watch right here. But we know what theta is. Theta is 40. So let's put that in there. 40 therefore plus angle beta is equal to 80 degrees, which means that angle beta is 80 minus 40, which means that angle beta is equal to 40 degrees. In other words, this line DB is a bisector of the angle. It cuts it in half. Because if the one on top, which is theta, is 40, and the one which below is beta is also 40, it means that that is a bisector. Now, in the question, they could have asked you, they could say, state one characteristic of the line DB. And you could say it is a bisector of the angle right? The angle 80 degrees. It bisects 80 degrees, right? That's a question they could ask. They didn't ask it in this one, but I just thought I'd mention it to you. The next thing we could say is if we consider the triangle DBC, consider triangle DBC, have a look at the DBC, and we add the angles in that triangle together, in other words 40 degrees, which is angle beta, plus angle alpha at the top, plus 70 degrees, must be equal to 180 degrees. 40 plus alpha plus 70 must be equal to 180 degrees. Because we know again that the angles in a triangle are supplementary. That means they sum up to 180 degrees. They add up to 180 degrees. So therefore, alpha plus, if we add 40 and 70 together, we get 110 degrees. It will be equal to 180 degrees. And therefore, from there, we could work out what angle alpha is. Angle alpha would be 180 minus 110, which is equal to how much? 70 degrees. Okay? So angle alpha is 70 degrees. But we know that angle alpha and y are alternate angles because they're inside that special z. That alpha worked out to be 70 degrees. So we know, therefore, angle alpha is equal to angle y because these are alternate angles. Therefore, angle y would be equal to 70 degrees. And that is the answer they're looking for. Okay, so somebody check and see if that's correct. Make sure I didn't make any errors anyway. Okay, so that's correct. Okay, so that's correct.